So let us consider the case of t is equal to 2. Okay, if an investor invests a unit amount, that is $1, okay, at time 0 over 2 periods, the investment will accumulate to 1 plus I2s to the power 2 at time 2. This is strategy 1, we have already seen. Okay. Alternatively, the investor can invest an unit payment at time 0 over 1 period and enter into a forward agreement to invest 1 plus I1s unit at time 1 to earn the forward rate of I2F for period 1. Okay, right. So, this rollover strategy will then accumulate to 1 plus I1s multiplied by 1 plus I2F at time 2. This is what you have simply understood using the numerical example. Okay. So, now, okay, we are putting it more formally and we will see here. Okay. So, here we will argue that the two strategies, okay, will accumulate to the same amount at time 2. Okay. So, that we will have 1 plus I2s, okay, to the power 2 is equal to 1 plus I1s multiplied by 1 plus I2f. Okay. So, remember this type of equation we have used when we have discussed in the expectation theory of term structure of interest rate. Okay, you just relate. Now I am actually making it more formal. Okay, so this equation hold if the capital market is perfectly competitive, so that there is no arbitrage opportunity. Okay, so what is the assumption of perfect competitive? I believe you have already understood the perfect competitive market, and therefore the assumption behind the perfect competitive market. Okay, an assumption for the perfectly competitive market is that here in our case in finance, the lending and borrowing rates are the same. Okay, of course, in practice they may be different, but we are assuming that the market is competitive such that, okay, the lending rate and the borrowing rate are exactly same. And what is the no arbitrage opportunity? Okay, so no arbitrage opportunity or the arbitrage opportunity, it simply means that opportunity to earn a risk-free profit with no investment. Okay, essentially arbitrage meaning that you are buying in one market and immediately or simultaneously you are selling it to another market, okay, with a higher price and then pocketing the profit, right. Let us understand a little bit clearly what is arbitrage. Okay, and then I will come back again to this equation. Okay, so what is an arbitrage activity? Now understand that suppose there are, suppose that the same asset is priced differently in two markets or two location. Okay, so remember what will happen. Okay, if like most of the time in the markets also, you might have seen that, like the prices are very similar, okay, in a particular market. Why? Or in fact in the location in the area. Okay, why? Okay, why the prices are exactly similar? Okay, if it is not, then there will be a price war, or like an investor, okay, a prospective investor who can easily take this price advantage, right, or the different price differences. That means he can immediately buy with a less price, okay, and sell it in other market with a little bit higher price. Same thing happened here also. So arbitrage is the purchase of an asset in one market and the simultaneous sale of the same asset in another market at a higher price, capturing the price difference as a risk-free profit. Okay, so arbitrage activity means you are actually making profit without any risk. You know that the price is less in one market and the price is little bit higher in the another market and you want to take the advantage, right. So in our case here, okay, why we are actually making the condition that there is no arbitrage opportunity, because if we are not making it, okay, that means if the left hand side of our equation, let's say 1 plus I2s to the power 2 is less than the right hand side of our equation, okay, 1 plus I1s multiplied by 1 plus I2f, okay, then an arbitrager will borrow 1 unit at time 0 over 2 years and lend 1 unit at time 0 over 1 year, okay, and at the same time, okay, he lent 1 plus I1s unit due at time 1 in the forward market over 1 year, right. So this strategy will therefore will guarantee him a profit of 1 plus I1s multiplied by 1 plus I2f minus 1 plus I2s square, okay, which is positive, right, and without any risk. So if he knows that, okay, a price is or like less in one market, then he can like immediately want to take that advantage, okay. So on the other hand, okay, if the left hand side of our equation, okay, is higher than the right hand side, okay, then the investor will lend 2 year in this spot market using capital borrowed from 1 year in the spot market with a forward agreement to roll over the loan for 1 year at time 1, right, and therefore, okay, therefore we are making this condition, right, this condition means that, okay, no arbitrage opportunity exists. If that is the case, then this equation must hold, okay. So now, okay, so the equation here says 1 plus I2s to the power 2 is equal to 1 plus I1s multiplied by 1 plus I2f can be generalized to grasp the relationship concerning the spot and the forward rate of interest, right. So that we can now write 1 plus ITS, okay, to the power t, okay, in place of 2 I have simply written t, okay, to generalize it, and therefore this portion of the equation becomes 1 plus I t minus 1, okay, to the power t minus 1. Remember here we have 1, right, the power 1, so we will have here, and then 1 plus I2 f. Now we can rewrite this equation for t minus 1 and repeated substitute, okay. So by repeatedly writing this 1 plus I t minus 1 s in terms of 1 plus I t minus 1 s and 1 plus I t minus 1 f, we can now, okay, conclude that 1 plus I t s, okay, to the power t is equal to 1 plus I1 f multiplied by 1 plus I2 f, okay, and we will go up to, we will have 1 plus IT f, okay. These two equations are very important, and important to notice here, it is known as implicit forward, okay. So given ITS, the forward rate of interest ITF satisfying this equation is known as the implicit forward rate, okay. So implicit forward rate, okay. Sometime we will see that the quoted forward rate and the implicit forward rates are different, but for our convenience we will assume that the implicit and the quoted forward rate are same, and therefore these are the implicit forward rates and proceed, okay. So we can compute the spot rate given the forward rate, okay, and the forward rate can be computed as ITF is equal to 1 plus ITS to the power 3 divided by 1 plus IT minus 1S to the power t minus 1 minus 1. This is the formula I have used in our numerical discussion. Okay. So, what we have seen here, okay, we can compute the spot rate, okay, given the forward rate, and we can also compute the forward rate given the spot rate, right. So, there is a relationship between forward rate and spot rate, right. Now, you will see here, okay, how to compute. Let us take one example and understand how to compute the spot rate given the forward rate and how to compute the forward rate given the spot rate, okay, using the same formula. So, take this example here, right. Suppose the spot rate of interest for investment horizon 1, 2, 3 and 4 years are given as 4%, 4.5%, okay, again 4.5% and 5% respectively. Calculate the forward rate of interest for T is equal to 1, 2, 3, 4. Okay. So, we have to compute the forward rate for period 1, period 2 and period 3 and period 4, right. Let us do that. So, how will be solution? So, for this, for the first, okay, we have to set that, okay, the forward rate in period 1 is equal to the spot rate of period, period 1. So, the first period forward rate therefore is simply equal to 4%, which is written here, okay, right. Now, to compute the second year forward rate, okay, forward rate for year 2, okay. Now, you can use the formula here as I2F is equal to 1 plus I2S to the power 2 divided by 1 plus I2 minus 1 to the power 2 minus 1 minus 1, okay. Then we will have here, what is this, 1.0.4, sorry, 1.045 square divided by 1.04, okay, minus 1. So, this is what 1.045, this one, okay, 4.5% here we are considering, right, and here we are considering 0.4, this one, right, okay. So, the forward rate for year 2 will become 5.0024%. Using the same formula or similar formula for, you can compute for period 3 now, okay, and also for period 4. How? Okay, I3F therefore is equal to simply 1 plus I3S, okay, to the power 3 divided by 1 plus I3 minus 1, okay, which will become 2 here, and here also will become 2. So, it will become square, okay, minus 1, and that is why I have written it here. So, realizing that you have already understood the formula, you can directly use the value here and you can proceed, right. So, we will have 1.045, okay, to the power, this is this one, right, 0.045 to the power 3 divided by again 1.045 to the power 2, this is this interest rate we have taken, okay, minus 1, which will give us a value that is 4.5%. Okay, so the forward rate for year 3 is 4.5%. Similarly, you can also compute it for year 4. Okay, so year 4, the forward interest rate for fourth period is 1 plus I2. Okay, this is same formula, but you are now putting this, like 4 in place of t and proceed, okay, and therefore using this we can have 6.5144%, Okay, the interest rate here we are taking like the spot interest rate, right? Here that is 0.5%, this one, okay, and the 45 here is the previous one, okay. So you will have 6.5144%. So what we have seen it here, given the spot rate, we can compute the forward rate, okay, right. So forward rate can be computed as 1 plus IT, okay, to the power t divided by 1 plus I t minus 1 to the power t minus 1 minus 1. That will be the forward rate, right. Now take another example, in which case we will see that given the forward rate, can we also compute the spot rate? Yes, of course we can do that, okay. So let us take the similar example but with a different rate here. Suppose the forward rate of interest for investment in year 1, 2, 3 and 4 are respectively 4%, 4.8% and again 4.8% and 5.2%. Okay. Calculate the spot rate of interest for 1, 2, 3 and 4, right. This is the exact same example we have here, okay, but in this case we have taken this 4.8% instead of 4.5% and 5%, okay. The rate are only changed, okay, fine. So let us now compute. I believe you can able to compute it easily, okay. So again initially, okay, for the first period spot rate which is equivalent with the first period forward rate which is also equal to 4%. So this is done here, right. 4% is done. Now you have to compute for I to S. What is I to S? Okay, remember we can use the formula here, okay. Now recall the formula that says 1 plus ITS to the power t is equal to 1 plus I1F multiplied by 1 plus I2F, okay. We will go on multiplying this up to 1 plus ITF, okay. So we can also write it for this ITS here as simply take this like take this to the power 1 upon t minus 1 and therefore we can write like ITS is equal to 1 plus I1F 1 plus I2F and it will go up to 1 plus ITF to the power 1 upon t, and this one we will take it here into the other side and therefore we will have minus 1. So this formula can be used to compute the spot rate, okay, given the forward rate. So if you know the forward rate, okay, of year 1, 2 and like so on, then you can easily compute the spot rate. So in our case here, therefore let us compute I to S, okay. So I to S, therefore using this same formula here, so we have here for only 2 years, so we will have 1 plus I1F multiplied by 1 plus I2F, okay, whole to the power 1 divided by 2, okay, minus 1. So we will have 1.04, okay, 1.04 multiplied by 1.048, okay, and take the square root, or simply will like have the this to the power 1 upon 2, this is the same. So minus 1 will give us 4.3992%, okay, right. Similarly we will have it for 3. I3S can be computed as, okay. So we will have for this is for 3 years forward rate now we are using. So we will have 1.04 multiplied by 1.048, okay, multiplied by 1.048, right, to the power 1 upon 3 whole minus 1. So, we will have 4.5327%, right. Similarly, we can compute it for period 4. So, we will have I4S, which will again, like I have taken 4 period here. So, 1 plus I1F multiplied by 1 plus I2F multiplied by 1 plus I3F multiplied by 1 plus I4F whole to the power 1 divided by 4, okay, whole minus 1. So, we will have 1.04 multiplied by 1.048, okay, multiplied by 1.048 multiplied by 1.052, okay, whole to the power 1 divided by 4 minus 1 will give us 4.6991%. So, now given the forward rate, okay, given the forward rate, you could able to compute the spot rate, and given the spot rate, we could able to compute the forward rate, okay. And what we have understood here is, like, spot rate are the rate, okay, which are for immediate transaction, but few forward rates are the rate that are for future transaction, okay, right. And of course, you have now understood the formula to compute the forward rate and spot rate, okay. In the next session, we will be taking it forward to understand the bond pricing, okay, under general term structure, right. So, again we have to recall our basic bond pricing formula and derive another formula, okay, for a general term structure, right. So, see you in the next session. Thank you.